Sergio and I'm the project leader.
Cisco, and I'm an R&D expert.
I'm Henrik and I'm an R&D expert.
Daniel and I'm an R&D expert.
My name is Alan and I'm a programmer.
My name is Johan, I'm a programmer.
My name is Jay and I'm the Java programmer.
The usage of mobile phones connected to a base station is forbidden inside airplanes. However, passengers often have the necessity to share files with their phones in this environment. This is a demonstration of a system that is capable of transferring files between two Android smartphones using a 3.5mm audio cable as channel and sending modulated audio signals through it. We start opening the application in both phones, then we select the mode and choose the file to transmit. Once the file is received, a pop-up message appears indicating if we want to open it.
Welcome to the OFDM part of the video. The idea here is to pick a file from the computer, convert it into a bit stream, map into a 64-QAM constellation and modulate the symbols into an OFDM signal. The samples are then sent to the transmitter phone to be played and recorded by the receiver phone. The received samples are then processed and the transmitted file should appear in the output folder, hopefully. Let's now start with the transmission. For that, we have two MATLAB scripts. The transmitter phone is currently connected to the computer and we should choose a file from the input folder which will then appear in the output folder if things go accordingly. Let's then run the script by typing OFDM-TX. First option that we are granted is to choose between a random stream or file. We choose the file we want and open it. In this case, we choose the KTH logo. The file is now going to be converted into a bit stream and modulated as an OFDM signal. Modulation has now ended. We can see the file as 64 kilobytes. Audio signal lasts around 6 seconds and the corresponding samples are sent to the phone in the format of shorts. The script found this device plugged and the expected achieved rate is around 85 kilobits per second. Let's now see these two plots from the transmitter. The first one shows a segment of the signal in time. The corresponding PSD is shown below. As you can see, we are using the whole bandwidth, approximately from 0 to 20 kHz. Now that the transmission is done, we must grab the samples from the phone and process them. For that, we run the script OFDM-RX. The script has now ended running. Let's see some plots to know what's happening. It first synchronized by using a cross-correlation method with a training sequence. We can also see the received PSD in this plot and compare it with the transmitted one. We can notice the gap and the low-pass components of the noise. Next, we see the estimated amplitudes and phases for each used frequency. We can see the non-linearity of the phase and that the gap was correctly estimated. After the modulation, the received constellation looks like this and the frequency offset effect is evident. After phase and amplitude correction, the constellation looks like this, which leads to a BER of 0%. We can now verify if the file is in the output folder. Here it is.